Okay, welcome back. This is rigid transformations on the coordinate plane. This video is part one, which is going to go over translations. After this, there'll be videos on reflections and rotations as well, so keep an eye out for those. Right, so let's jump right in. Right here, we're asked to translate this shape 3 units down on the coordinate plane. And that's pretty self-explanatory, right? A translation is just any time you can think of a translation as a slide. It's when we're sliding a figure somewhere around the coordinate plane, left, right, up, down, however we want to move it. That's a transformation. So in this case, we're just asked to translate it 3 units down. Now, when we first start this, I tend to see students trying to translate the entire shape all at once. They basically take one look at it, they say, I have to translate that 3 units down, and then they kind of just, they start trying to draw the shape in. And what they end up with is a shape that's maybe about the right number of units translated, but it just doesn't look right. And so the trick with transformations is you really need to think about it one vertex at a time. And if you don't remember, a vertex is just this point right here where two lines meet. Oh, sorry, I used a better highlighter for that. It's where two lines intersect, where they meet, right? They terminate right here where they start. So M, L, and N are the vertices on this particular figure. And so we have to move them down, and we need to do it one vertex at a time. So we're just going to start, pick one, and start counting down, in this case 3 units. So we're going to start at L, 1, 2, 3 units down, and we can put our first point, which is L prime. Prime just tells us it's the copy, it's the image. And then we'd start with N, we'd go 1, 2, 3 units down, and put another vertex, label it N prime, and then finally we'll take point M, go 1, 2, 3 units down, and see that it actually ends up where L was, so M prime. And this is why we label them, right? Because I should use a different color. This is why we label them, because we need to keep track of which point corresponds to which point on the image corresponds to the points on the pre-image, right? L prime corresponds to L, N corresponds to N prime, and so on and so forth. All right, so this is pretty easy. This is just transformations on the coordinate plane, and you can count, you can draw. If you're visual, this works pretty good. But what about when you don't have a coordinate plane, or when you want to check your work and make sure you're thinking correctly about it? Well, that's when there's some math that comes in. So what I want you to think about is what is happening to the x and the y coordinates of our image once we've translated it, right? We have our pre-image that starts up in the pink. Once we've translated those coordinates down to the purple, well, what is changing? And so to help that out, maybe we'll just do a comparison up here. I have point L. Point L on the original is going to be, let's take it down here. L is -2, 0. Well, what is L prime? Looks like L prime gets moved down to -2, what did I do? I'm sorry, L gets moved down to -2, -3. So L gets moved to -2, -3. Well, what changed between those 2 points? Right, we have the x coordinate and we have the y coordinate, and what changed? Well, it looks to me -2 stays the same, and that makes sense because we did not slide the image left or right. Right? We didn't slide this to the left or to the right. It's still any coordinate, it keeps its x coordinate. But what did change is, well, the y changed. We went from 0 and we went down to -3. And so, well, what math happened there? And I mean, I'd hope it's pretty obvious, even if it's a relatively open-ended question. All we did is we took 0 and we subtracted 3 from it to get to -3. And that's how we do transformations. We just have to think, okay, are we adding to or subtracting from any of the points? And if we are, well, is it the x coordinate or the y coordinate? And so in general, the rule we're going to use for all of these is we're going to take our original point up here, we're going to rewrite it with the x coordinate exactly what it was, right? That's the -2 in this case. And then we're going to take whatever the y coordinate was, and in this case, we're moving 3 units down, so we're going to subtract 3 units from it. And you can see if you do the math, we've basically just made a tiny little computer program. We say, all right, start at -2, put it right into the x, and what you get out really is just another x. Take our 0, take take our y equals 0, put it in for y, and if you do, in that case, 0 minus 3, well, what you get out is the negative 3. And I'm sorry, I made a little mistake here. We're going to change that back to what the x originally was, which was negative 2. And so that's our rule, and that's kind of what you want to remember. If you're translating up or down, you're basically just changing the y coordinate. You're either going to subtract to move down to translate down, and you're going to add to the y coordinate to translate up. Okay, here we have a translation 2 units left. And so I'm not going to run through the entire thing. I think we can see that if we move this figure 2 units to the left, we'd be over here. And we can use 1 point as an example here, just to make sure that our rules and our understanding forward over. So let's look at g and g prime. So g, we are over 1 and down 1, so we are at positive 1 comma negative 1. And g prime, it looks like in this case, we are over negative 1 on the x coordinate and down 1 on the y coordinate. And so again, I ask you to, well, what changed? And maybe I could have used a better example because we're all dealing with negative 1s here. But we can see in this case, the y coordinate stayed the same. Y is negative 1, and that's because, well, we weren't moving the shape up or down, right? We were just moving it side to side. So the only coordinate that's going to change is the x coordinate. And you can see that right here. In this case, it looks like we just subtracted 2 from it, which makes sense because we're moving the unit, the whole thing 2 units to the left. So let's test our theory. If we had our original g, which is 1 comma negative 1, and we put it into our little machine we've worked out here, in this case, that's going to be take, g prime. In that case, that's just take whatever coordinate we have for x, subtract 2 units from it, and then take whatever we have for y and just leave it alone. That should work. That should get us there. So let's take our x value, put it in. We see that we have to take 1 and subtract 2. And so that should put out a negative 1 for us. And then we say we take our y coordinate, and that just says, well, keep it. So we bring it down here. We write negative 1. And that's our new point, right? That makes sense. We're at negative 1 comma negative 1 for g prime, and we've done it. We've translated the shape. That's a lot of information, and it's really fast, and I went pretty quickly, and I did that because, well, you can slow me down in the YouTube interface, or you can pause me if you need to. So I invite you to please do that, and if any of this was helpful, make sure to get it into your notes so you have it for later.